Okay, for the second part of this video on systems of linear equations, we're going to look at one more method for graphing lines, and that is using the slope-intercept form of a line. Okay, this is called the slope-intercept form. Y equals mx plus b. And in this case, we have the coefficient in front of the x is the slope, okay? So m stands for slope. And the constant in the equation, which we're calling b here, is the y-intercept. So if you change your equation from general form into slope-intercept form, you can then see what the slope is, and you also get a point on the line, the y-intercept. We're going to look at now how to use that information to graph a line. So let's go back to our same line, 4x minus 2y equals 10. I want to rearrange this equation so that it reads y equals mx plus b. Alright, so the goal here is to leave the y term on the left side of the equation and move the x term to the right side, because the x term is on the right side in this form. So I will leave 2y here. 4x is moving to the other side of the equation, so it becomes minus 4x instead of plus 4x. And this stays as plus 10. So this equation is beginning to look like the slope-intercept form. We have y, or a multiple of y, equals a multiple of x plus a constant. The only thing we have left to do now is make this 1y, not minus 2y. So everything gets divided by minus 2. I like to divide each term by minus 2 because later on we're going to look at these two terms individually and get information from them. So this leads us to y equals minus 4 over minus 2 simplifies to 2x. And 10 over negative 2 simplifies to minus 5. This represents the same line that we graphed before with 4x minus 2y equals 10. What we get from this form of the line is that negative 5 is the y-intercept, where it crosses the y-axis, and 2 is the slope. All right, so slope consists of rise over run. This is 2 over 1. Okay, so anytime you have an integer as your slope, it's over 1. Let's use that to graph the line. We will begin with the y-intercept. We know that this is a point on the line, negative 5. From that point, we should be able to use the rise and the run and still remain on the line. So from negative 0, negative 5, I will rise 2. 1, 2, and run 1. 1. Okay, so we went up 2, and we went right 1, and we land right here. When we connect those 2 points, we have a line. So let's do that. It goes forever in all directions. Okay, great. So we have the same line we had before that has the y-intercept of 0 minus 5 and the x-intercept of 2.50, except we got to graphing this line in a different way. Remember, you find the y-intercept, and from that point, you use the slope. I think of it like it's stairs, you know, rise 2, run 1, and you're back on the line. Okay, Well, there's also a slope formula because every line has a slope that can be determined by knowing 2 points. And the formula for slope is y2 minus y1 over x2 minus x1. This gives us the change in y, or delta y, over the change in x, which we know as rise, which is how much the y changes, over the run, how much the x changes. I'm going to let you practice with 2 points on our line. We have 2.5, 0, and another point, the other intercept, was 0 minus 5. Use the formula to calculate the slope of the line that passes through these 2 points. One thing to note about this formula, y2 and y1. It doesn't matter which y is 2 or 1, as long as you are consistent. So we maybe want to begin by calling this x1, y1, x2, y2, and plug them into the formula. If you try it the other way around, you will see that it makes no difference. Pause the video and calculate the slope. So m is equal to y2 minus y1. y2 is negative 5. Subtract 0. Over x2, 0. Subtract 2.5. Okay, that leads us to minus 5 over minus 2.5. This reduces to positive 2. And that's the slope we found for that line before anyway, by putting it in slope-intercept form. Okay, some general things about slopes. Positive slopes lean right. Negative slopes lean left. Lines with equal slopes are parallel. And lines whose slopes are the negative reciprocal of each other are perpendicular. All right. An example of that. Put in another color so you can see it a little more easily there. If I have a slope, we'll call it M1, and it is 2 over 1. A perpendicular slope to that is going to be the negative of this. This is a positive value, and so the negative of that is a negative, and the reciprocal. These two slopes are on lines that are perpendicular to each other. Okay, a little time for you to practice now. For each of these lines that I have drawn, 1, 2, and 3, find the slope and y-intercept of each line. So pause the video, write these down, and then when you come back on, I will have the answers for you. All right. Since these are already in slope-intercept form, we can see the slope is the coefficient of x. So in this case, m equals 3. And the y-intercept equals negative 4. For this one, the coefficient of x is the slope, which is negative 2/3. And the y-intercept is 1. And this one, the coefficient of x is 1. It has a slope of 1. Rise 1, run 1. And the y-intercept is actually 0. Okay, well, you can see that when an equation is in slope-intercept form, the slope and the y-intercept are very easy to see. Let's have a practice on when it is in general form. So now, this equation is in its general form, not the slope-intercept form. Find the slope and y-intercept for this equation. Pause the video, give that a try. All right, in order to find that, we would like it to be in slope-intercept form, which means I am going to leave the term with y on the left-hand side, and I will take the term with x to the other side, and I begin to put it in y equals mx plus b. The last thing to do is divide every term by the coefficient of y. So that's over -5, and that's over -5, and that is over -5. Tidy that up. This negative divided by negative is a positive, and a positive divided by negative is a negative. All right, now it's in slope-intercept form, and we can see that the slope is 2/5, and the y-intercept is -5. All right, that is really all I need to say about graphing linear equations. If you are going to solve a system of linear equations graphically, all right, we would plot both lines. And see where they cross, okay? This point is the only point, xy, that satisfies both equations. So where they cross is the solution to the system of linear equations. All right, in class we are going to look at finding the solution in an algebraic way. But by graphing them, you can also get an idea of what the solution is. All right, thanks for watching, and I will see you in class.